In the chaos of outer space, and in the heart of every galaxy, there lies a black hole, these dark, infinitely dense, inescapable holes in the universe. But there's much more to them than just their density. Black holes as we know them today were theorized about a year after Albert Einstein published his general theory of relativity in 1915. This theory described how matter curves the fabric of space-time, which is where gravity comes from. Physicist Carl Schwarzschild set out to solve Einstein's field equations, the equations that describe the curvature of space-time. In doing so, Schwarzschild came up with this. Pretty confusing, right? Essentially, this equation describes exactly how space-time curves outside of an object. When the r variable, or the radius, is set to 0, or the exact center of the object, you'd have to divide by 0. A similar thing happens here, where at a specific radius, the denominator of this fraction would also become 0, which is where the equation breaks down and blows up to infinity. This is called Schwarzschild radius, which is where the idea of an object with infinite density first came from. The Schwarzschild radius is the radius an object would have to be at its current mass to become a black hole. For example, the Earth's Schwarzschild radius is 8.8 millimeters, meaning you'd have to cram all of the mass in the Earth into an 8.8 millimeter space for it to collapse into a black hole. This was thought to be impossible and the stuff of science fiction up until 1971, when astronomers discovered some very odd events happening in the Milky Way galaxy. You see, a black hole's gravity is so incredibly powerful that it can distort the light that's being emitted from nearby stars. Astronomers found a group of stars orbiting an invisible mass that seemed to be doing exactly this. This object was generally agreed upon to be the first discovered black hole, but we wouldn't take a picture of a black hole up until 2017, when the Event Horizon Telescope took this picture, a landmark in astronomy and physics.